Hello, and welcome back. This video is about showing how to implement double jump, air dash, and charged jump, and thrusters with gliding. And a special thanks to all my supporters. Thank you for helping me help others. I started with a fresh Unreal Engine 5.6 third-person C++ project I named Jumpy Jump Jump. So we'll start with double jump because it's the most complicated. We go into our third-person character, do a search for jump max count, and we have this value. We set it to 2, and there we go. So with that done, you can hit jump, jump again, mash it a bunch of times, and you'll get 2 jumps. Of course, that value is just a number. You can set it to some other value. And we get 4 jumps. I guess we just revert that back to 1 for now. So for each of air dash, charge jump, and thrusters, I added 3 new input actions. These are all just default type, so you just right-click, input, input action. So in there, this is set to bool as a value type, and there's nothing else that has been changed. The default value means you can subscribe to started, triggered, and completed. So in the input mapping context, then we just added air dash to shift, charge jump to C, thrusters to X, and we're good to go. So the changes needed are in our CPP file. We have the air dash, charge jump, and thruster actions. For air dash, we have an air dash velocity. So this is just the value that overrides character's velocity used in the air dash function. If I search down to air dash, we have an air dash function here. In our setup player input component, air dash is just being set from the air dash action, and it's on started, which means on the key press going down. So in this function, all it's doing is making sure that we are on the ground, otherwise it would not be an air dash. And all it does is take our forward vector, gets safe normal, so it's normalized. We're multiplying it by that air dash velocity, and we're just launching the character in that direction. The 2 values that are true here are for overriding X and Y and Z, or if you prefer, Z. If we hit F12 on LaunchCharacter, you can see what it does in here. And effectively what it's doing is it's getting the final velocity from the value we sent in, and then if override is false for each of these, it will add the current velocity before it then calls launch on the character movement. And in there, it's effectively, the end result is just it's setting the velocity to this new value. So what that looks like in here is we can then jump up and hit shift, and it just dashes us forward. If you want to go to the side, it works just fine, but because the character does take a little bit of time to go to the side, you can have a case where you're facing forward, you start to turn, and you can see it didn't go exactly 90. If you wanted to, you could also make the left and right be based on the camera's forward, and then you just have to get the camera's right vector instead and multiply it, depending on the input. Next up, we have charge jump, which similarly we have up here. We have the action is created, charge jump action, and then we have a bunch of variables that are being set. So for charge jump, we want to first save the Z or Z velocity. And this is what is being set in the editor. So we're saving that value after it's been set. And then we have a variable which is just the amount above the normal jump Z velocity that we want to limit the held value to. We have the actual held value. And then we have the value that held is increased per second. So then the functions for that down here are, we're subscribing to the entire set of started, triggered, and completed for charge jump. So then the first thing that we have up here in our begin play is we're setting our start jump velocity to the one that's from the character movement component. And we just save that so that we can use it later. In our setup player input component, then, like I said, we're doing started, triggered, and completed for charge jump. And then in these functions, When we start our charge, so when we hold down C, the held charged jump velocity is being set to that initial velocity. Otherwise, if you just tapped C and you didn't set this to a value, it would be a very small jump. We want it to be at least the base jump and then higher. As we hold it down, jump or charge jump triggered gets called on every tick. We're getting the delta time that's used for that tick, and we're multiplying that by the charge jump rate to add it to the held value. And then we're just limiting to the maximum, which is the base start jump velocity and the charged jump velocity modifier that we had set. So by default, this is 500 and we set this to 500. So it's going to be a jump with twice the velocity of a normal jump. And then when the charge jump is completed, which means the key has been reset, we're setting our jump velocity to the one that we generated for the held value. And then we're just calling jump. The reason we're calling jump specifically is so that it uses the same jump logic. If we had a double jump, that's built into the movement component and the character component, and calling jump here will respect that. What that also meant, however, is that up here in our jump action, I changed from just calling jump here to calling myJump. And what the myJump function is, all it is it's setting the jump velocity back to that start value and then applying it as a normal jump. So what that looks like is in here, and I've set up some UI elements. On the bottom left is our charge jump. So as we hold down C, it gets increased. And when we release, that's the full charge jump. So if we just tap it, we get a normal jump. We go halfway, we get halfway, 750 or so velocity. The bar on the right side is our thruster one, which we'll talk about next. But while I'm talking about that, if we go into here, I created a WBP HUD. All that we have in our HUD here is showing the two progress bars. One is charge bar, the other thruster bar. They were both set to bottom to top, and they both have in their percent, we just bound a function to get that value. So if we look at the function for charge bar, what's happening here is we're getting our owning player pawn, which is our third person character, and we're just getting the held value minus the start value. So the held value starts at the start value. So this minus this is going to start at 0 and then go all the way up to the jump or charge jump velocity modifier, which we set to 500. So this range here is from 0 to 500 divided by 500. 500 puts it in a 0 to 1 range. For the thrusters and glide, we have another bunch of variables. First of all, we have the max thruster duration, which is the amount of time that you can use the thruster. We have the current thruster duration. This value starts at 0 and then it gets incremented by thruster gain rate, 1 per second, up until the 2 value here. And the thruster gain tick rate is just how often the timer function gets called. We could have used tick, but I wanted to show this in C++ code as well. So the tick rate is how often that function gets called. And also the tick rate times the rate is the actual value that gets added to thruster duration. We then have two values for thruster force and thruster glide force, because the way that thruster is working in this project is we're calling LaunchCharacter in with a vertical direction of these values. And then we just have a timer handle for the thruster gain. We scroll down to our functions. We then just have thrusters triggered. So obviously that is on when that button is being held down. Every tick, that function gets called. And then we have the actual thruster gain timer function. So in our CPP file, if we scroll up to begin play again, we're getting the world timer manager so that we can set a timer. We send along our timer handle. We send along the class that owns the function we're going to use. And then we send along the function itself, very similar to binding an action down here. And then the rate at which it ticks, so every 0.1 seconds. And then lastly, it's just this true or false just means whether it's going to call that function over and over in a loop. So with that, again, we have our thrusters action. We're subscribing to the triggered event and calling thrusters triggered. So actually, before we talk about that, we have our thruster gain timer function. So if the character is not on the ground, we just return, which means when the character is on the ground, we're increasing our thruster duration by a value of our gain rate multiplied by the gain tick rate, and we're limiting it to the max thruster duration. So then every tick, this function gets called. Again, we're just getting the delta time so that we can apply it to thruster duration. If our thruster duration is positive, which means we have thrust left, we're setting our thrust direction vertically, so 0, 0, and then up based on our thruster force. I picked 1200 because it just worked for testing and whatnot, you can play around with these values. And we're multiplying that by delta time so that we can then down here call LaunchCharacter. We're setting along that thrust duration. We're setting along false because we want to be able to move horizontally while we're thrusting. We're also setting false here because the logic is that we're applying the thruster force every tick, which is also why it's multiplied by delta time. Unlike jumping, where you just apply it the single time, this being applied over and over has a little different functionality. If that thruster duration was above 0, we want to just make sure we reduce it by delta time so that when it runs out, we're now using a thrust direction based on the glide force value. The glide force value is set to 700, which is just a little higher than the gravity value, effectively. So what does that look like? So in here, we're on the ground. Anytime you're not on the ground, our thruster force in the bottom right is not increasing. We hold the thruster button, we go up slowly until it ends, and then we glide down. We're giving ourselves some up velocity on top of the gravity velocity that's pushing us down. So we can combine the things, use the charge jump into a dash, or into a thrust, go even higher, a dash. And lastly, I'll show the HUD for the charge or the thruster bar. So all that's doing to show the percent is just getting the thruster duration over the max thruster duration. Simple. 0 to 1. Thanks for watching. If you liked the video and would like to see more, you know what to do. And if you would like to support this channel, watch these videos 2 weeks early, or just want to download the project files, you can do so through my Patreon linked below.